All right, so we're going to talk about rational exponents today. Rational means fraction. Exponents. So we have exponents that are fractions. So the question is, how do you do that? You guys might recall. I mean, you know how to do a regular exponent, right? If I put 5 to the third power, that means you do 5 multiplied by itself 3 times, right? And I would get 125. You ever remember what negative exponents do? It doesn't make the answer negative. That's the most common assumption. But do you guys remember what negative exponents do? Oh, it makes it a fraction. So it's still 125. It's just that it's 1 over 125. So that's what negative exponents do. And we'll see a little bit of that today as well. But this should probably be new. You probably haven't seen that before. So we're going to talk about how to handle that kind of a situation. All right, and those are called rational exponents. So I'll kind of walk you guys through the process of how to figure out what these things are. Right now I'm going to say I have no idea what that is. So I'm going to put a question mark there. Okay. Now I'm going to use a property about exponents, though, to see if I can maybe simplify this a little bit. You don't need to write what I'm going to write over here on the left side of the board, but I just want to make a point. Does anybody know what this is equal to? Yeah.
X to the 6th power.
X to the 6th power. So basically, that's right. So if you have a term with a power on it and you raise that whole thing to a power, you multiply these together and you get 6. Okay? And so why does it work that way? Well, that means we have x squared 3 times. And you might remember another rule we learned is that when you're multiplying all these, you add their exponents up. So you can think of it that way and do addition and get 6, but this is faster if you just do 3 times 2. Okay? So I'm going to use that property of exponents to handle this situation. What can I multiply 1/3 by so that it's not a fraction anymore? 3. Yeah. So how can I multiply the exponent? Well, I can multiply the exponent if I raise this side to the 3rd power. And by doing that, I'm going to multiply those together. 3 times 1/3. What does 3 times 1/3 make?
3.
It makes 1. I'll show my work on the side here. 3 times 1 is 3 over 3, which is 1. So it's just going to be 8 to the 1st power, which I'll just say is 8. Now, I got rid of the part that I didn't understand by raising the side to a 3rd power. I'm allowed to raise this side to a 3rd power if I what? Raise the other side to a 3rd power. Okay, so I've made it look different. I still haven't gotten my answer yet, but now that it's written like this, maybe that'll help us a little bit. I want to know what is 8 to the 1/3 power. Well, by rewriting it like this, I've rephrased the question now. Now I'm asking what number to the 3rd power is 8?
2.
And the answer is 2, right? Now, so we know now the answer is 2. So basically what this thing is asking is, when you see this, it's asking you what number raised to that power gives you this. Or what number multiplied by itself that many times makes that. So let me give you another one here. Suppose I have this. What number multiplies by itself twice to give me 9? 3. So 9 to the 1/2 power would be 3. Or let's do another one. How about this one might be a little bit harder for you. What number multiplies by itself 4 times to make 16?
2.
All right, so 16 to the 1/4 power is 2. Now there's another way we could ask this question. Instead of writing it like this, what number multiplies by itself 3 times to make 8? Well, that's what we did yesterday, isn't it? what number multiplies by itself 3 times to make 8? That's what we did yesterday. So here's another way you could think about it. So this way was confusing to us. This way made more sense to us, but I want to connect it to what we did yesterday. So here's what I want you guys to understand about these. 8 to the 1/3 power, that's the same thing as the third root of 8. What number times itself 3 times gives me 8? Okay? So 8 to the 1/3 is the third root of 8. Now, what if I have this though instead? Well, I'm really going to handle it the same way. First of all, think of it like this instead. Do you guys agree that I can change this into that?
Yes.
There's nothing wrong with that. I just take the 2 off and I put it out here, because if we multiply those together, we get what's there. So I just rewrote it a little bit. Why did I do that? Because I already know what this is. What's 8 to the 1/3? It's 2, but it's the third root of 8, which is 2, right? Squared. So if I get rid of this middle chunk here, we now have kind of a shortcut that we're going to be using for the rest of the day here. When you have a number being raised to a fraction power, the bottom number is a root. The top number is your power. Okay? So that's going to be the first thing that we're doing today. So go ahead and take a moment and write down this slide. I'll give you a little bit. So for the remainder of our day, we're just looking at some example problems here. Okay, so let's go ahead and call this example 1. And I think I'm going to have 2 examples, so we'll call this A. So example 1, part A, the directions are at the top. Write each expression in radical form, and then the problem is b to the 1/4. So go ahead and copy that down, give you a sec. All right, so I have v. I'm going to write it over here. I don't like how far over to the left it is. So I have v to 1/4. I just want to rewrite this in radical form. And so I'm going to write a radical. The bottom number goes here. The top number, I'm going to put it out here, like that. So the 1 goes out there, the 4 goes down there, and then the v goes inside, just like that. That's it. We're just rewriting it right now. We're not going to solve anything. We're just rewriting it. All right. So let's take a look at another one here. Go ahead and write down this one. We'll call this one B. Or B. 10n to the 1/6 power. Okay, we got 3 blanks to fill in here. So I'll ask Vidal, what goes here first?
6.
Yeah. And Shakir, what am I going to put underneath of the radical here? 10 and the n, right? I'll put some parentheses on there. And then finally, Steve, what am I going to put out here? Steve.
Oh, I'm sorry. 1.
Good. The top number. There you go. So that's the first thing I want you to know how to do is rewrite it. So I'll give you guys a couple seconds just to practice it a little bit there, and then we'll see what you guys get. So there are our answers. All right. Let's go ahead and take a look at our next problem. So with our next problem, we're going to actually simplify it. We're not going to just rewrite it. We're going to find out what the answer is. All right. So go ahead and write down example 2. We'll call this A. All right. So step 1 is going to be to rewrite it. So we're going to do a radical. What number goes here? 2. And the 64k to the 4th goes here. And then out here we're going to put 3. All right? So the next part we're going to do is we're going to simplify the root. We're going to simplify the root next. So that's this part. Okay? So I'm gonna show my work on the side and just put my final answer here. So 64k to the 4th. 64 is 8 times 8. K to the 4th is 4 k's being multiplied together. So the 64 split up, the k to the 4th split up, the 8 split up, the 4 split up, but I'm left with all these 2's here and all these k's. So I have 1, 2, 3, 4, 5, 6 2's. And 4 k's. And we're taking out groups of 2. All right? So I can take out a 2, another 2, another 2, okay, and another K. And by the way, with the problems I'm giving you for these types of problems today, they'll always work out perfectly where you'll have a perfect number of groups on the inside. So your root should go away in the end. So notice there's nothing left in the root, so we'll just get rid of that. And I've got 2 times 2 times 2, which is 8, and k times k, which is k squared. So I'm going to put my final answer there now. So 64k to the 4th is 8k squared. I'll wait in case you're still writing. So basically step 2 is the stuff that we did yesterday. So step 1, rewrite it. Step 2, do what we did yesterday. Step 3, do the power. So, someone with a calculator, can you tell me what 8 to the 3rd power is? 512. All right. So we apply the 3 to the 8 and also to the k. What's k squared raised to the 3rd power? What did we say we do with those when we have a power being raised to another power? We multiply them so you get 6, yeah. So we have 512k to the 6 is my final answer. Okay? So 3 steps, rewrite it, simplify your root, and then do the power that's on the outside. Okay? Here's part B. Go ahead and write down part B. This one we'll kind of do together. Let you guys handle some of the steps on your own. So write down part B, please.
Where did you get
On the 8? Yeah. This 3 on the outside, you apply it to as a power to both numbers. So the 3 goes here, so you have 3. And then 3 times 2 is 6. Okay, so go ahead and do the first step on this one. I'll wait for you guys for a second, then I'm going to ask you what you got. Go ahead and do the first step for do the first step. Calling you just a second to share out your answer. Might want to check with a neighbor there. All right. Yes. DeAndre, what'd you get for the first step there? Working on it? Go ahead, Dave.
Is there 4 root 635 the power of 4 and that's the power of 3.
Good. That's correct. All right, now the next step is going to take you guys a second, but go ahead and do step 2. You're simplifying the root. And once again, it should work out perfectly. There should be a perfect number of things to take out. Now, also notice that you guys are doing a 4th root, not a square root. So you're taking out numbers that are in groups of 4. Okay? I'll give you a second. You were gone yesterday, so that's kind of a cheap shot. Sorry. Let's see. Crystal, what did you get for step 2? It's just 5n, right? Now that's what's in the parentheses, but we still have that 3 on the outside, which moves us to our last step. So that one won't take you too long, but I will give you a second to calculate, and then I'll ask you what you got. If you want to see how we got 5n, I will write the steps up while you guys are working on step 3. But all right, so Alonzo, what did you get for 5n to the 3rd power? Good. So that's 5 to the 3rd. And then we're also going to raise n to the 3rd. So since there's nothing there, you can just kind of like do 3 times 1 is 3. So the final answer would be 125n to the 3rd power. Okay? So there's your 3 steps. Rewrite it, simplify it, do the power. Okay? Check our time here a little bit, see how we're looking on that. Yeah, 32. All right. All right, let's have you guys try one more here completely on your own. Instead of me walking you through it step by step, just go ahead and knock that guy out, and then I'll be right with you. For step 1, you guys, you should have rewritten it like this. Maybe you included the 2 on the outside or not. It doesn't matter. You don't have to put the 2 there. And step 2, you should have found the square root. Now, the square root of this should have come out to be 9k squared. And after you raise it to the 1st power, it doesn't change, and so your answer is just 9k squared, your final answer there. Now, I want to show you guys one more thing before you guys pack up. Let's go ahead and, what letter did I leave off on here? All right. Let's call this B. What if the exponent is negative? Because you will see some questions like that on your homework. So like, for instance, let's take this guy. The one that we just did. And let's say it was a negative half instead. Well, the answer is you get the same thing. What was our answer for this? 9k squared. I still get 9k squared. Everything's exactly the same. The only difference is, yeah, it's 1 over 9k squared. That's it. So, in other words, what if the exponent is negative? Do the same thing. Just write it as 1 over your answer. Okay? So that's it. Everything else is the same. There's really not a whole lot to mention. That's a good question. I don't plan on getting in the negative ones, but we did talk about how to deal with negative roots yesterday. So like if it was a square root, you would cross it off and you put an I in the front, right? If it's a odd root, you put a negative in the front. So that's how you deal with it. But I don't think that I'm going to give you problems where these are negative on these ones. The ones from yesterday, yes. These ones, no. Why? Because the computer only makes questions like this, and I don't like to create my own. Yep. All right, guys. Huh? I've already been going around looking at notes. You guys are good. You guys can pack up.